Welcome to Basic Electricity Tech TV, where we will be taking the mystery out of basic electricity. Hello, and welcome. Welcome to another episode of Basic Electricity. In this episode, we're going to build a series circuit, check the resistance of that series circuit, and finally check the amperage and voltage of that series circuit. And hopefully we'll gain a little bit of knowledge and a little bit of practical experience with the series circuit. So let's get started. Okay, in our study of series circuits, the first part of the series circuit test is learning how the resistance works in a series circuit. Now we are in the Learner view. This should be what you are seeing. We'll go to Assignments, click on Assignments, scroll down to Resistance in a Series Circuit, and the references are here. The wiring diagram manual 240003, sheets 1 through 6, the equipment list, and the resistor color codes. And it says review the assignment's wiring diagram 240003, sheets 1 through 6. Review the equipment list to determine which resistors to use. Calculate the total resistance for each one of the diagrams 1 through 6. Mount the resistors on the breadboard as per a wiring diagram 240003, again sheets 1 through 6. Connect your meter to read resistance, and in a separate Excel spreadsheet, create a table like the one below. Use a colored pencil or a highlighter to trace the path of current flow on both the schematics and the assignment's diagram. Upload a picture of the highlighted assignment's wiring diagram, 2400 sheet 5. Calculate the total resistance for each wiring diagram, 1 through 6. Use your multimeter to measure the total resistance for each wiring diagram. Enter your findings in the table. Compare your calculated values and your measured values, and whether it is within limits. Upload your Excel spreadsheet to D2L. Upload all 6 pictures of your circuit with your meter in the picture, and no email subscriptions will be accepted. And this will be the table. Wiring diagram 240003, calculated resistance, measured resistance for sheets 1, 2, 3, 4, 5, 6, and is it within limits. Let us shrink this up and bring up our spreadsheet. This is a version of my spreadsheet, and this is a version of series circuits in wiring diagram. The difference is I've used light bulbs, whereas in your wiring diagram I expect you to use resistors. And in the wiring diagram, let's bring it up. That will be the wiring diagram. And we are talking about series circuits 240003. Open that up. And this is what it would look like on your breadboard. A wire coming in, attached to this rail, a wire going from that rail up to the first resistor, out of the first resistor, and out to your meter. And of course all 6 resistors are here. And again, I expect you to use R3, R4, R5, R6, R7, and R8, and you can find their values in the equipment list. And if you scroll down, this is sheet 1. This is sheet 2. Notice the wire changed from up here to down there on sheet 2. And the wire moved to the 3rd position on sheet 3 of 6. And the wire is now in the 4th position on sheet 4 of 6. And the 5th position, sheet 5 of 6. And finally, the very last position, sheet 6 of 6. Let's get back to our spreadsheet. And this will be our spreadsheet. Now I know that the bulbs I'm using in my circuit are all roughly about 100 ohms. So I'm just going to use that value. But to measure resistance, the first thing I'm going to do is disconnect power from my circuit. Measuring resistance, I want to disconnect power because if I have power connected to it, I will get a false reading. So I will connect my meter to this point, through the wire, through the breadboard, through that wire to the first resistor, through the first resistor, and out to my meter. Now I told you the value of each resistor, each light bulb here, is about 100 ohms. So in this position, let me clear this up for a second. I will trace the path of current flow. Let's make it red so I can see it easily. Current flow is going to come through the wire, through the breadboard, through the wire, through the first resistor, and back out. Bring up my calculator. Now again, I know the value is already 100, so I'm going to simply add on 100 and equals. And my calculated value I will enter in here, 100. And let me insert my omega symbol, and I'll move it over just a little bit. Oops, didn't mean that. And just to clear things up a little bit, to make it a little bit easier to see, we'll turn them all red and bold. Okay, my first resistor measures at 100. As I move to sheet 2, I have to move my wire to the 2nd position. Now my current flow is going through 2 resistors. And bring my calculator up. That should be 100 plus 100. Let's do that. 100 plus 100 gives me a value of 200. So on sheet 2 of 6, I should have a value of 200. And again, let me insert the omega symbol so I make sure I'm talking about resistance. Sheet 3. I'm going to move my wire down 1 more position and highlight my path of current flow. Current flow through there, through the board, through the wire, through each resistor and back out. Connect my bring up back my calculator, and I should have 100 plus 100 plus 100 should give me 300. So 100 plus 100 plus 100 gives me a value of 300. 300. And again, I will insert my symbol for resistance. I will set my resistance up for sheet 6. Oh no, sheet 4. Highlight my path of current flow, and now through the wire, through the breadboard, through the wire, through 1, 2, 3, 4 resistors, and back out. Bring up my calculator, and that should be 100 plus 100 plus 100 plus 100. So that's 100 plus 100 plus 100 plus 100 should give me 400. And I will enter that into my spreadsheet, and again insert my omega symbol. And sheet 5 of 6, I have to move my wire down one more position. Have to highlight my path of current flow, bring back my calculator, and 100 plus 100 plus 100 plus 100 plus 100. That should be 100 plus 100 plus 100 plus 100 plus 100. Should give me a value of 500. And I have a value of 500 entered in there. Let me put my omega symbol in again. And finally sheet 6 of 6. And again, I will highlight my path of current flow coming through my wire, through my breadboard, through my wire, through 1, 2, 3, 4, 5, 6 resistors, and back out. Bring my calculator back up, and that's 100 plus 100 plus 100 plus 100. Oops, I screwed that up, didn't I? Let me clear that whole thing. 100 plus 100 plus 100 100 plus 100 plus 100 plus 100 should give me a value of 600, and it does. Put my value in there, and my omega symbol. Okay, now just to cheat a little bit, I put down my values are down there. My measured value was 99. My second measured value was 199. My third measured value was 299. My fourth measured value was 402. Oops, not 403, 402. My fifth measured value was 502. And the last measured value was 603. And of course, 199. Is it within limits? Yes. 200, 199. Is it within limits? Yes. 300, 299. Is it within limits? Yes. 400, 402 is within limits. Yes. 500, 502, again within limits. Yes. 600 and 603, is it within limits? Yes, it is. Okay, now I can actually analyze everything. And yes, everything is within limits. Let me just make sure I have all of that. 99, 199, 299, 30, 402, 502, and 603. Here, if anything is out of limits, that's where I should start to recognize or look for problems. If the numbers are way, way off, then there was a problem. Something went wrong. I have to go back in and check it to find out. If I see an OL on my meter, there is a broken wire or an open circuit somewhere in my system. If I see numbers that are way high, then something else went wrong. Or if I see numbers that are very, very low, there may be a short circuit somewhere, there may be something else going on. I have to go check if I find something that is very far out of limits. If it's within limits, then it's good to go. And that's how we analyze resistance in a series circuit.